Hello, it's Bagoon with another video in my Learn to Trigger for Age of Mythology Intermediate series. Today I'm going to be talking to you about the Terrain Paint trigger and the Terrain Paint Elevation trigger. So, if we look at the new type test, you'll see we've got Paint Terrain Elevation and Paint Terrain. So, having a look at this, you can see that we can set an area and define the terrain type and then update the passability. So what this means is we can set an area as the bottom corner and an area as the top corner, and if we just leave this blank we get grass A. So have a look, and these dots will now disappear. A similar sort of effect if we're looking at painting terrain elevation in area. Again, we can set a certain area, we can put in a height number and see what happens. So there we've just got a nice smooth flattened area because the elevation is all the same. So the elevation one's fairly straightforward. You can set it relative to the height where you place it, and that just means it's going to make it a bit taller, whereas if you turn that option off you get the absolute height. The terrain has a few more different parameters though. So we have types and subtypes, and we have passability. So in Age of Mythology there's lots of terrains. They all have different types and subtypes. So you'll see there's grass types. They all have different types and subtypes. How would you find out what these are? Well, from our last video, we've got Notter's command viewer, so you'd look in there and you get a directory of all the terrain types. If I just do this one for 2-2, this outputs Egyptian cliff. Funnily enough, you'll find I can actually walk on this, and I can actually build on this. That's because I haven't told the map to update the passability. That was our other ball option at the end. If this is checked off, you can just paint terrain, and the behaviour is equivalent to what you had before. So if I'm turning my cliff from grass, it means it behaves as grass and I can still build on it. However, if I've got a cliff and then I'm changing it to grass, you'll find that you can actually walk on that. So let's put a bit of unbuildable terrain there, just to prove a point. So even though that's caught in the cliff, it's still treated as impassable because it was originally cliff. If I change the ball so I do update the passability, it instantly refreshes the terrain on the whole map, and now it behaves as cliff and I can't walk on any of it at all. That's the paint terrain in area. You'll see there's a few more of them. So if I do the paint terrain in area manual, you'll see I get to manually input the coordinates in here. So how does this work? This is slightly different to the meters system we've been using to check unit distance. This is the tile system. So it counts the tiles up in varying directions. So if I do 0, 0 in the from, it will start from this tile here, because this is tile 0 right in the corner of the map. If I say, let's go 10 up and 5 across, without updating the passability, you're going to see that's what happens. So I've painted the cliff terrain like that. There's also the possibility of painting the terrain in a circle area. So if we do this one, we start at the centre, let's say 5 tiles in, and we get something like this, a nice circle of terrain. So that's passable because I never refresh the passability, so it doesn't really matter what terrain I'm going to paint there. It's always going to behave as what was there before. Let's say I paint the entire thing cliff, so that unit shouldn't be able to move, and let's make it grass and then make it cliff, and I'm updating the passability on the grass one rather than the cliff one. So it's going to set the entire map to grass A, which is passable, refresh, and then we're going to build some cliff and not refresh the passability. So with this one, even though it was originally all cliff briefly there, I can walk everywhere I want to on here. If we now take a look in the command viewer for this, we can see all the terrains listed in alphabetical order with major and minor integers associated with them. So if you wanted Gaia Creep Sand, you'd find that on here. You'd see it would be major 0 and minor 10. So you would input 0 into the type and 10 into the subtype unless you're able to free text it. So if we look at the XS code here, we're going to be taking an integer for the next position, an integer for the Y tile, an integer for the X tile, an integer for the Y tile, a type, a subtype, and then a bool of updating obstruction. So it's going to look something like this if we use XS user code. So what I'm going to do is I'm going to input this for the black terrain type, which is major type 5 and minor type 4, and then I'm just going to need to set my coordinates in here. So if I want to paint terrain using XS user code, I just paste what I've done there, but I'd need to define the tiles. So let's say start at the bottom of the map and go up and have a square of 6 tiles. Let's have a look. So we've got that black square, terrain is not refreshed, so it's behaving as cliff, and our unit can't walk. Now let's do something advanced with this, because we've got the option of XS user code. I can put any integer I want into these values. So let's say I want a looping trigger that's going to paint the terrain underneath a unit. So we'd need to be able to get the unit position as a vector, and then we need to convert the separate components of that vector into an integer to fit here. I'm going to put a slight break in here, have a pause, have a look at the command viewer, try and find the commands that will do this, and then try and actually write the code before I tell you what the answer is. So, having a look at the command viewer, you may have come across the command kb get block position, returning a unit's position as a vector. You then may have also found xs vector get x, returning the x component of that vector as an integer. These are the commands that we're interested in. So, I could do tr paint terrain xz 5 4 false, and I could replace this with XS vector get and then the block position inside. However, unfortunately, we would then exceed a character limit in the command line of 128 characters, and it would cause a trigger lock. So we need a way of simplifying this and making it a little bit easier. So what I'm going to do is I'm going to create my own vector called pos, and I'm going to define that as our kb get block position, and we're going to input the string of 0, so that's now our vector, and instead we can just now have xs vector get x pos for our x coordinate, and xs vector get z pos for our z coordinates. And if we test this now, we should have a looping blackness under where Arcantos walks. So Arcantos is walking around. Doesn't seem to be happening, but it is in the top of the screen. So what's going on here? This is because of the difference in tiles and meters. So this kb get block position is returning a unit's absolute position in meters. The terrain, as we've already discussed, paints in tiles. So in order to convert our meters into tiles, we need to divide everything by 2. So if I just put divide by 2 next to all these integers, because of BidMass and order of operations, this will now work. So now when Arcantos moves, we have the terrain painting underneath him like so. I hope that's been useful. So in this one we've looked at inputting our custom data types into more complicated triggers to create some rather cool effects. And now as a final challenge, I'm wondering if using what we've already learned during this series, you'd be able to go into the type test and make a trigger like this. And it's going to accomplish exactly the same thing. So have a look at the trig temp, have a look at the previous videos, figure out what parameters we'd need and how we'd get this unit, and you should be able to do something like this. I'll see you again in the next video.